Hello students. So here is the question of the day. Day 1. Topic is the center of mass. This week we will cover good questions of center of mass. Right. This is a very good question. Very important question. First you can pause the video here. See this question carefully. This question I have taken from Pathfinder. So why I have chosen this question today? Because of its simplicity. Right. This question is there in check your understanding section, looking like a difficult question, but if you are choosing properly your approach or brainstorming angle, then this question can be a very easy question, right? Now what is the question? Basically, on a horizontal smooth surface, we have three blocks, or you can say three discs. The middle disc having mass 2 kg and outer disc are having mass 1 kg. The middle and outer disc are connected with a string of length 50 cm. Middle disc is projected with a velocity 2 meter per second. Now we need to find tension in the threads when the end discs are about to collide. Right? So when the end discs are about to collide, we need to find tension in the string. So now, what is the approach for this question? You can give yourself at least 2 minutes for this question, no problem. Now what should be the approach of this question? We can apply work energy theorem in center of mass frame. In center of mass frame, we can apply first work energy theorem to find velocity of the end disk when they are just about to collide. Now center of mass frame is a inertial frame, you can say, right? So with respect to center of mass, if you see acceleration of center of mass is 0, so change in kinetic energy of the system with respect to center of mass should be 0. So that is a very important factor. The change in kinetic energy should be 0 in center of mass frame, as center of mass is an inertial frame, right? So with respect to center of mass, that is initial kinetic energy, only middle disk is having a relative velocity. So velocity of center of mass, if you are trying to obtain, it is just m1 into v1 plus m2 into v2, that is 0, divided by total mass of the system, which is 4. So center of mass velocity is 1 meter per second. That is velocity of center of mass. Okay. So with respect to center of mass, initially only this middle disk is having velocity 1 meter per second. That is kinetic energy, right? Now when the system is about to collide like this, then in the vertical direction, say that is vertical direction, in this vertical direction there cannot be any relative motion, because we know string is unstretchable, means this component should be equal to velocity of center of mass. So in center of mass frame, the only velocities of the end discs are there, right, due to which they are about to collide, right, this component. So this component you can say v dash, and their parallel components are equal. This parallel component should be equal to velocity of center of mass because of no relative motion, right? So with respect to center of mass, we can write directly kinetic energy as half into m into v dash square into 2, right? So that is a very beautiful property in this question. So in center of mass frame, we are writing kinetic energy, and directly one component of velocity of disk we are getting. So we are getting this as 1 meter per second, right? Now again, here if you see, masses are such that acceleration of capital M and small m are equal, that is T by 1, right? Tension T by 1. So on bigger mass, I am talking about magnitude. So tension is 2T, mass is 2 kg, so it is a T by 1. Similarly for this smaller disk, tension is T and mass is 1, right? Now I am writing force equation on one small disk, say left disk. I am writing force equation, tension acting up, right, pseudo force. So this I am writing with respect to this bigger disk. So with respect to bigger disk is having a acceleration down, right? Down means like this, negative y-axis you can say, and that is pseudo force, right? So tension pseudo force up minus mv square by r centrifugal force is equal to mass into acceleration of m, right, upward. Now in magnitude these two things are equal, so we can cancel these two things. So then directly tension we are getting mv square by l, right? So what I am getting beta, tension T as substituting the value I am getting 2 Newton, right? Now in many other books or in many other sources I have seen the solution of this question is very big, but otherwise it is a very easy question you can say. The only important thing is here brainstorming angle, the correct approach. By that you can get the answer very easily, right? So any doubt is there in the comment section, please write, go through this question, right? Very important question. Thank you.